Woohoo! It's a great day to learn some pre-cal. I'm Miss Leg Battles, and I'm here today to talk to you about conic sections. Today, we want to be recognizing the conics in their general form and also completing the square when they're in their general form to put them in their standard form. First of all, it's really easy to recognize conics in their general form just by looking at the coefficients of x squared and y squared. If the coefficients are the same, it's a circle. If the coefficients are different but have the same sign, it's an ellipse. If the coefficients are different and have different signs, in other words, one's positive and one's negative, then it's a hyperbola. And if there's only one squared term, just an x squared or a y squared, then it's a parabola. So let's look at some examples. I have 4 examples for us to look at. So let's look at those coefficients. For number 1, we have a coefficient of 4 and a coefficient of negative 25. Those are different coefficients with different signs. That is a hyperbola. For the next one, the coefficients are exactly the same. They're both 1. So that is a circle. For number 3, look, there is just one squared term, y squared, but no x squared. That makes it a parabola. And finally, on the last one, notice we have the coefficient 9 and 25. They have the same sign. They are both positive, but they're different numbers, so that makes it an ellipse. Now we're ready to take some equations like this in their general form and complete the square to put them in their standard form. First, let's determine which conic this is, because we're going to complete the squares to transform each equation of a conic section into its standard form. So I want to know what it is, so I'll know what its standard form is. So for number 1, the coefficients are exactly the same. So that means this is a circle. And of course, to put it in standard form, this is the equation we're going for. X minus h quantity squared plus y minus k quantity squared equals r squared. We know hk is going to be the center and r is going to be the radius. So let's group together the x's. We'll put the x squared plus 4x together, and then we'll put the y squared minus 6y together, and we're going to move that constant to the other side. When we add 23 to both sides, that's what we get. So now I'm going to complete the square. To complete the square, we want to make this a perfect square trinomial. I'm going to take half of 4 and then square it. Half of 4 is 2. 2 squared is 4. And if I add 4 to the left, I have to add 4 to the right. Next, I'm going to complete the square on this part. Half of negative 6 is negative 3, and negative 3 squared is 9. So I'm going to add 9. Now we see that we've made both of these perfect squares. This is x plus 2 quantity squared. This is y minus 3 quantity squared. And then the 23 plus 4 plus 9 gives me 36. So now I have this in this wonderful, nice standard form, so I can just read right off that center would be negative 2, positive 3. The radius, if r squared is 36, the radius is 6. So I want you to notice this perfect square. If I square x plus 2, I get x squared plus 4x plus 4. And if I square y minus 3, I get y squared minus 6y plus 9. If you don't believe me, you can write it down twice and use the FOIL method to multiply it out. So remember, we're completing the square by taking half of the coefficient to the, for the first one, the coefficient to x, which is 4. And then we're squaring that to get 4. We took half of the negative 6 to get negative 3. We squared it to get 9. Now I have a couple of problems for you to work. So copy these down and make sure that you show your work. On your problems, I want you to write down as much work as I did on my problems. Now let's look at this example, number 4. The coefficient to x squared is 9. The coefficient to y squared is 4. They are different. They are both positive. That makes it an ellipse. So this is that standard form that we're headed to. So let's group our terms again. We're going to group our x terms. I have 9x squared minus 18x. Then I'm going to group my y's. 4y squared plus 16y. And then I'm going to put that negative 11 on the other side. When I add 11 to both sides, I'll have just 11 over here. Now, next, I want to factor out these coefficients. So I'm going to factor out the 9 here, and I'm left with x squared minus 2x. I'm going to leave a space because I'm going to complete the square there. Now I'm going to factor out a 4 here, and I'm left with y squared plus 4y. Again, I'm going to leave a space to complete the square, and I have 11 on the other side. So, what do I need to complete the square? Half of negative 2 is negative 1, and negative 1 squared is 1. So I'm adding 1. Now, because I have the 9 factored out, I'm really adding the value of 9 to this side, 9 times 1. So I'm going to need to add 9 to the other side. To complete the square on the y's, half of 4 is 2. 2 squared is 4, so I'm going to need to add 4. But I'm really adding 4 times 4, which is 16. So I'm going to have to add 16 to the other side so it doesn't change the value. So now I have 9 times, and this is now a perfect square. It is x minus 1 quantity squared plus 4 times y plus 2 quantity squared equals 11 plus 9 plus 16, which is 36. Now, remember, I'm trying to make this 1 over on the right-hand side, and I can do that if I just divide everything by 36. That's going to take care of everything. So when I divide by 36, then I get it in this nice, beautiful form. X minus 1 quantity squared over 4 plus y plus 2 quantity squared over 9 equals 1. And there we have it. We've matched up that form. We now have what we would need to graph this ellipse. Now I have 2 problems for you to do. So copy these down and make sure to show your work, just like I did. So after the initial problem, I have 1, 2, 3, 4 steps. So I want to see your 4 steps when it's an ellipse. Here's my next example. I notice there's a coefficient to x squared is 4, and the coefficient to y squared is a negative 25. They are different, and they have different signs. So that makes it a hyperbola. So I jotted down one of the standard forms for a hyperbola. You know, that x minus h could come first or it could come second. But this is the general form that we're looking for. So we're going to do like we did previously. We're going to group our x's. And on this one, the x's are already grouped together. Then I'm going to group the y's. Well, those are already grouped together as well. But I do need to put the 489 over on the other side. Now I'm going to need to factor out that coefficient. So here it's a 4. When I factor out 4, I'm left with x squared minus 6x. I'm going to leave a space to complete the square. Here I'm going to factor out a negative 25. So be careful, it's a negative 25. So that's going to leave me with y squared minus 10y. You can check by distributing back. Negative 25 times y squared is negative 25y squared, and negative 25 times negative 10y gives me that positive 250y that I was needing right there. So again, I'm going to leave a space to complete the square, and I have 489 on the right. So, first of all, when I complete the square here, same routine. Half of negative 6 is negative 3, squared is 9. Now that's a perfect square. But I'm really adding 4 times 9 to that side, so I have to also add 36 to the other side. Then I'm going to complete the square on the y's. Half of negative 10 is negative 5, squared is 25. But I'm really adding the equivalent of negative 25 times 25, which is a negative 625. Now, let's clean this up a bit. That's going to give me 4 times my perfect square trinomial there. That's x minus 3 quantity squared minus 25 times y minus 5 quantity squared equals, and 489 plus 36 minus 625, that gives me 100. Now, to get it in the right form, I'm going to need to divide everything by 100. When I divide through by 100, gives me 1 on the right, helps me figure out what a squared and b squared would be. So I now have x minus 3 quantity squared, and 4 goes into 125 times, minus y minus 5 quantity squared over 4 equals 1. So there is my nice form. So I'm all ready to graph that hyperbola. Now I have a couple of examples that I want you to work for me. So do these, pause the video so you can copy these down, and make sure you show your work. On the hyperbola, just like on the ellipse, you're going to need 4 steps after you write the initial problem. And that brings me to our last example. Y squared plus 2y plus 12x minus 23 equals 0. And I notice that there's only one square term. There's a y squared, but there is no x squared. That makes it a parabola. That means I need it in one of these forms. Of course, it's the y term that's squared, so it's really that first form that I'm going for. So let's put our y's together so we can complete the square, and let's put everything else on the other side. That's going to give me negative 12x plus 23 over on the right. Now, to complete the square, half of 2 is 1, and 1 squared is 1. So I've only added 1 to this side, so I just add 1 to the other side. Now I have my perfect square. This is y plus 1 quantity squared. And over here, I have negative 12x plus 24. Well, I'm going to need to factor out that negative 12 so I can have it in the form that I need. So when I factor out negative 12, I'm left with x minus 2. Now remember, I'm factoring out a negative, so you can check it by multiplying back out. Negative 12 times x is negative 12x. Negative 12 times negative 2 is positive 24. So this is my standard form for the parabola. Now I have a couple of problems for you to work. Do number 11 and 12 and make sure to show your work. On these, you're just going to have those 3 steps after you copy the initial problem. Well, thanks for hanging with me through this video. Woohoo! It has been a great day to learn some pre-cal. And as an added bonus for sticking with me to the end, I've got a few of our answers. So what I've done is provided you with half of the answers for the ones I ask you to work. That way you can check your work and make sure you're on track before you submit your work to me. Hope you have a great day.